Hello everyone, this is Mrs. McCrary. Today we're going to talk about discounts and percent. We're going to be looking at sections 45 and 46 from Pure Mathematics. In section 45, it tells us that a discount is the amount remitted when principal is paid before the end of agreed term. So this is an extension of the interest that we were talking about before. Excuse me. Discount then, if you pay a loan or an amount before the agreed upon time, you won't pay as much interest, so that interest that you're not paying is what is being referred to as discount. Now there are two ways to find discount. There's true discount and banker's discount. The true discount is the amount remitted in proportion to a principal of 100 pounds, of $100, 100 any units, for the same rate of time. So we're looking at, in an ideal world, if all of our numbers were nice and happy and we were using 100 to go with our percentages, how much would you be paying if it was all based on nice happy hundreds? A banker's discount is the amount remitted using the simple interest practices, using adjusted time value. When we multiply 6 times a third, we get 2. And then we multiply 2 times 100, get 200 divided by 100, and we get 2. So we would have our interest would be $2. Our interest plus our principal would end up as $102. Our first example states, find the difference between the true discount and the banker's discount on 306 pounds, due 4 months hence, at 6%. So the first thing we need to do is find what the amount would be, the pay amount, defined last time as the principal plus the interest, for a value of 100 pounds. So remember from last time, to find our interest, we have principal times rate times time over 100. Now in this case, we're doing our hypothetical amount of 100 times rate, which is 6, times time. Now we have to be careful because our time in this equation is always going to be in years. So we have to look at that value of 4 months and think, well, what does that mean in years? Well, 4 months is actually a third of a year, so we're going to be multiplying that by a third and dividing by 100. So that is our hypothetical value. Now that's going to be in proportion to our real value, so we have 102 would have been what you paid if you had used 100, compared to 306. We have $2 is to our true value, or in this case I'm going to use a T to help us remember that it's the true value. Now we set this up just like all those other proportions we worked with. So we've got $102 over 306 equals 2 over T. Rule of 3, we multiply terms 2 and 3 and divide by divide by our first term. So 2 times 3 is going to be 6. 12 divided by 102, 6. Okay, so in this case our true discount is going to be 6. Oh, I'm sorry, it's in pounds. 6 pounds. Okay, so there is our true discount. Now let's find our banker's discount. Oops. Now our banker's discount, we're still going to be using the same equation for interest. We're just going to go ahead and plug in the values that we have and see what we get. So our principal in this case is 306. Our rate is still 6, and our time is still 1/3 over 100. Okay, so again, when we multiply 6 times a third, we get 2. When we multiply 306 times 2, we get 612. And then when we divide by 100, we get 6 and 12/100ths of a pound. So you can see there is a bit of a difference between the true discount and the banker's discount. We have this extra 12/100ths of a pound that would come into play if you were working with the banker's discount. And if you go back to your compound numbers, you can put that into the next value down. But just be aware that there is that difference. You will be asked for one or the other specifically if you're being asked to use those. All right, in our example 2, a bill of £350 drawn on March 15th at 6 months is cashed on May 20th, 1872. What is the banker's discount at 6%? All right, so if we were to solve this for when it had been due, that would have been, I believe your text says September 18th, and since it was then cashed on May 20th, that ends up being 120 days earlier. 121, I'm sorry. Now, since 121 days doesn't compute easily into a fraction of a year, we're going to use a proportion to look at that. So what we need to find is how much you would have paid in interest to find that third value, because we're going to be looking at how much you would have paid over 365 days compared to how much the interest is now going to be over 121 days. So we need to find that first interest value to find our new interest value that we're looking for. Okay, so again, we're just going to be setting it up with our principal times rate times time over 100. So we have 350 times 6% times 1 over 100. And when you work all that out, that ends up being 21. All right, so we have 365 over 121 equals 21 over x. All right, now you're just going to solve this as you would a regular proportion. So following your rule of 3, you're going to multiply 121 times 21 and divide by 365. And when you solve that, you end up with 6 and 351 over 365. And then, of course, that can be converted into shillings using your compound numbers. Or I don't mind if you leave it as a fraction. All right, so in Pure Mathematics, section 46, there are many questions which relate to ordinary transactions which may be worked exactly as if we had to find simple interest for 1 year. Those cases include, but are not limited to, commission, brokerage, and insurance. Now, commission is a sum of money charged by an agent for buying or selling goods at a certain percent upon the value of the good. Brokerage is a sum of money charged by an agent upon money transactions at a certain percent upon the value. And insurance is a sum charged percent upon the value of a property, the said value being paid to the insured in case of loss from causes as per agreement. All right, so find the brokerage on $793.48 at 4.5%. So we're again going to use that same principal times rate times time over 100. We are just going to, in this case, our time is always going to be 1. All right. So our principal is that is not right. Our principal is 793.48 times 4.5 divided by 100. All right, so simple multiplication and division here. We have 793.48 times 4.5. We're moving this 1, 2, 3 places, so we need to remember to move it back 3 places at the end. So 4, 24, 15, 17, 46, whoops, 35, 39, 0, 32, 16, 19, 12, 13, 36, 37, and 31. One, two, three. Okay, so there is our multiplication, and then we divide by 100, so we're dividing by 100, so that means we're going to be moving our decimal place 2 more places to the left. 1, 2. So we end up with $35.70. All right. Another example, a person insures 1,050 pounds at 3 3/4%. What is his annual premium? Okay, so again, we have 1,050 times 3.75. You could leave it in a fraction and divide by fractions. It's fine. Divided by 100. Again, we have the time there, but in this case it's 1. When you multiply by 1, it doesn't change anything, so I just haven't been writing it. Okay, so 1,050 times 3.75. Alright, so we moved our decimal 2 places, 1, 2. Again, dividing by 100, moving it another 2 places to the left, 1, 2. So in this case, we get, now here would have been a good place to work in fractions, because now I have a decimal of a pound. Not that you can't convert it, but it is easier to convert from pounds to shillings if you have fractions, but it's not my main concern at this point. So we have 39.375 pounds, or of course you could write it as 39,375 over 1,000 and convert from there. All right, so hopefully that helps you with the decimals and percents. These are different percentages than what we are normally used to thinking of, but still, you know, we're just using that same simple interest formula that we used last time. And again, remember, we have principal times interest times time divided over 100. And then from there, it's just calculation. So let me know if you have any questions.